Hi and Assalamualaikum. Welcome to Coatings World. So greetings everyone. Do you know what is coating? Can you find out objects with coatings around you? There are a few examples of coatings in our daily lives. For example, table coatings, car parts, wall painting, kitchenware, and color painting. So, what is coating? Coating is a polymer layer which forms on the surface of an object when it is applied. So, there are basically four primary components in coatings. The first one is binder. It is a polymer that plays the main role in film formation, provides strength, and bind pigments together. The second one is pigments. It provides color. The third one is solvent, which acts as a medium to dissolve the binder and form coating layer of film. And lastly is additive. It improves properties of coatings and adhesive and only required in small amount. So we have conducted a mini experiment for you guys. As for the mini experiment, we will need a plastic spoon, bottle containing water, candle, dye, lighter, and an A4 paper. So firstly, we will lit up the candle so that the wax will cover on the surface of the A4 paper. You will need to make sure that all of the surface of the A4 paper is covered with a layer of wax. Then, you will need to add a few droplets of dye into the bottle containing water by using the plastic spoon. Shake the bottle to make sure that the dye completely mixed with the water. Add a few droplets of the mixture onto the A4 paper that is coated with wax. And take another A4 paper and add also a few droplets of the mixture on the surface of the paper.
A few moments later.
As you can see, the paper coated with wax doesn't absorb dye and stays as a droplets, while the paper with no wax coatings absorbs dye. So why do you think the water stays as a droplets on the wax paper? So the answer is due to the wettability.
From the experiment, we are using wax. Waxes are one of the most hydrophobic substances constituted by long-chain 10 to 60 carbon atoms, compounds such as fatty acids, alcohol, ketones, aldehyde, and ester. These characteristics makes them unique to be used as anti-wetting agent in coating. So, do you guys understand about what is wetting? Let us explore it together. Wetting is the ability of liquids to maintain contact with a solid surface, and it is controlled by the balance between the intermolecular interaction of adhesive type and cohesive type. After we understand the definition of wetting, let me show what is contact angle. In the diagram, alpha is the contact angle. As from the experiment, we know that paper with wax is wetting, but paper without wax is easily wetting by the dyes. Why does this happen? This is due to wetting is happen on hydrophilic surface, while the wetting is happen on hydrophobic surface. In all systems which water interacts with another surface, both adhesion and cohesion are factors. When adhesion is more of a factor, we will get a sheet of water as shown, whereas when cohesion is more of a factor, the water forms spherical droplets as shown in previous mini experiment. In the mini experiment, cohesive force is stronger than the attraction between the water and the wax. This is why the water droplets stay on the wax paper. Besides, when the contact angle is less than 90 degrees, wetting occurs. On the other hand, when the contact angle which is alpha more than 90 degree, the wetting occurs. In a nutshell, we can observe that the importance of wax coating from the experiment. In coating, wax functions as anti-blocking agents. Second, it can help improve sleep properties. For example, harder waxes enable better sleep properties. Sleep enables two surfaces to glide over one another without inducing any mechanical damage. Third, waxes help in creating abrasion resistance via a combination of basic properties like strength, hardness, elasticity, lubricity, particle size, toughness, and in certain cases, thickness. Last but not least, paraffin waxes provide surface protection against water. To sum up, waxes are employed in formulations because of the advantages they provide in terms of surface enhancement and properties. That's all. Thanks for watching.